So welcome everybody to this meeting. This is our very first meeting as CloudForceSky, where we are going to be guided through the solution for the first challenge we had, our first weekly challenge. And to guide us today will be one of our own, Marcrine Musimbi. So without further ado, I'll hand over the microphone to her and the screen so that she can take us through it. So Marcrine, over to you.
Yes. Thank you, Patrick. Can you hear me?
Yes, we can.
Okay, enable screen sharing. So, week one challenge, you are supposed to come up with a solution for a tech company that currently has a one-tier architecture. So, we're supposed to come up with a three-tier architecture so that their system will be highly available, secure, and cost-effective. So, to draw an architecture, you need to use these tools. Maybe, for example, you can use draw.io or you can use Lucidchart. So for me, I'm going to use Lucidchart. You can see on my screen, this is a blank document for Lucidchart. So you have to come here to the shape library and you choose the shapes you need to use. So we're going to use AWS architecture for 2021, the latest and at least selected ones. I'll just close the unnecessary shapes. For an architecture, first you have to show that it is AWS Cloud. You can either use this shape or this one. I'll choose the second one. You just drag and drop. It's that easy to draw an architecture. AWS Cloud, the top. And then when you already have the cloud, you have to choose a region where you'll put your services. Okay, remember we are doing this for the company and anyone is welcome to correct when I go wrong anywhere. After choosing the cloud, you choose a region. Now that you have a region, the next step will be to choose you need a VPC, and then the AZ always pans out the VPC. So for high availability, you need to have like 2 or more AZs to achieve high availability, so that when one AZ fails, the other one will take control and there will be no downtime for the application. So for region, you have to choose which region you want to reside in. It can be maybe US East or Central. So if you're going with US East 1, for availability zone, you can maybe choose US East 1A and US East 1B. As you can see here, this is just the basic part of an architecture. Are you getting me, everyone? If you're getting me, you can say yes or anything. Patrick?
Yes, we are following. Yes, very
Oh,
clearly.
yes, okay. So with Lucidchart, it's easier because you just drag and drop. As you can see, it's very easy. And if you want to edit, maybe here, you just double click on the text and maybe we'll name this the availability zone A. Yeah, and this one we can name it availability zone B. And there you have your AZs, VPC, and region, and the AWS cloud. So if you see anywhere that maybe a company is telling you they're facing availability issues, just always think about multi-AZ. That's always the solution to availability. So for a three-tier architecture, you need to have the presentation layer. That's where the users interact with when they go to a web page and maybe they search for anything, maybe google.com. So the page that comes that is presented here, this is the presentation layer. Users interact with the presentation layer. So the presentation layer should always be public in the public subnet. We need it to be in the public subnet. So we'll come here and check for a public subnet and we'll put it here inside the AZ there. And you can just edit the way you see fit. You don't have to do exactly as I am doing. Yeah. And also this public subnet, we want to replicate everything that is in AZA to be in AZB. So Lucidchart, it's easy. You just click duplicate and you can just drag and drop it here. We've observed availability for the public subnet. Now we have to choose an EC2 instance, assuming that our client is deploying their application on an EC2 instance. So you come to compute, the compute section. And you can see we have a lot of EC2s, different types. T2 micro is for free tier, and there are others. So it will depend with the client, maybe their workload. Maybe their workload needs M5, maybe T3 medium. But for today, we're going to use a T2 micro, assuming that we want to use a free. Okay, this is for demonstration purposes. But now when you're dealing with the client, they have to tell you how their workload is, and then you can decide on what EC2 instance to use. But T2 micro is free for 750 hours if it's running. So for high availability, anything you do in availability zone A, you have to do it in availability zone B, so that when this instance fails, this one will pick up from where this one has left. And our clients or users, people using our website, won't have to face a downtime. Even they won't notice that maybe a server is down or anything. It will just be smooth for them. And then when a client get into your website, this website will interact with a backend service. So this one, will just call this one a front-end service. Maybe we've created using HTML, CSS, and all that, or maybe frameworks like React, but you can use anything to create it. So our backend service should always be in a private subnet, because we don't want everyone to interact with it. It's just meant for a few people, a few authorized people. I'll duplicate this one. Yeah. So with the backend service, you can still deploy it in an EC2 instance. And because we are demonstrating, I'll just use a T2 micro. There it is. Deploying in an EC2 instance, you can use different ways. Maybe you can clone the project in the EC2 instance and maybe run it using Tmux, or you can Dockerize your application and push the images to a Docker Hub, and you can pull it in the EC2 instance and run it. There are different ways of deploying in an EC2 instance. We'll talk about that in another challenge. So this is our backend service. In a backend, okay, let's say it's an API. There are API endpoints. So what happens here is when someone comes to your website, for example, I'll go with ALX. This is their page where the backend comes in. Maybe if someone wants to log into a system, when you come here, maybe there is a sign up page. The data that you feed there will have to be saved somewhere. It will have to interact with the backend, and maybe it will be saved in the database. So this page will interact with the backend, and maybe it will render another page where someone is authorized to carry out some actions. Yeah, and now the backend service will always interact with the database. And your database, it should always be in the private subnet, because we don't want hackers or anyone to just come in and check out your data. We want it to be safe. So it should be in the private subnet. So you put it here. Or maybe you can decide to put the database and the backend service in one private subnet, but I'm choosing to put it in a different private subnet. It just depends how you want to design your database. It all depends with you. Yeah, there. So when it comes to databases, you have to decide which database is the best. Now it will depend with the client. Maybe they want a NoSQL database or a SQL database. If they want a NoSQL database, maybe you use DynamoDB. But if they want a SQL database, the client, maybe they want Aurora or PostgreSQL or maybe MySQL. It will just depend with their data and their preferences. So for demonstration purposes, I'll go for MySQL there. So for database, you have an option to choose multi-AZ, so it can replicate itself automatically, which is considered to be expensive, or you can just create it afresh in another AZ. So depending with the client, you'll decide whether you want to create it afresh or you'll use the multi-AZ option. But here, we're going to create it afresh in another AZ. So your main AZ, this database that is here, we'll call it a primary database because it's the best database. And this one will be a secondary database, which is on standby, just in case this database fails. This one will take over. So now we've achieved high availability. there is no single point of failure. Everything is replicated. And if this one fails, you can use the other one. And you can choose to have different ASICs, maybe 3, 4, and replicate everything there. It all depends on you. Now, another thing, security. When you see this diagram, we've achieved high availability and cost. So like 42 micro, it's free. And depending with the clients, there are different EC2 pricing plans. Maybe they can choose to use spot instances or reserved instances or on demand. They'll just decide, but you have to consider the cost too. So for security, when you see security in the cloud, you have to think NACLs or security group. For NACLs, if you don't want to go through all these shapes searching for something, you can just come here and search. I'll search for NACL, network access control list. And you can see we have it here. And you have this one, VPC network control access list. You can choose any. So NACLs, they're placed at the subnet level. Like they protect subnets, all subnets. You can place the NACLs on each subnet. Yeah, like that. You can just duplicate it and place them there. The NACLs, they are stateless. Like you have to create a rule that maybe allows traffic to different ports. And you also have to create another rule that allows that same traffic to come out. And to protect your instances, you'll have to use security groups. So you have to create a security group and come up with rules for different ports. Maybe you want to use port 80 or port 8080 or maybe port 443. We'll discuss more on ports maybe in another challenge. So security groups. Yeah. So security groups will protect your instances. You can use one security group for multiple servers, or maybe you want to choose different rules for different servers, so you'll have to use multiple security groups for different servers. It will all depend with you. Now that we'll achieve security for our instances and our public subnets. For this public subnet to interact with the world, you need to use an internet gateway so that it will be open to the world and people can use your application. So you place the internet gateway on the VPC. Okay, this is just for demonstration purposes. I'm sure when you take time, you can create something better than this. For icons that are users and clients, here they are. You can either choose to use a client. It's just the same thing like users, or you can choose to use this icon. It will all depend with you. And that is it. For our public subnets to interact with the world, we need an internet gateway. Another thing, scalability. So to ensure that your architecture is highly scalable, you need an auto-scaling group. So an auto-scaling group, it will scale automatically in and out. When the demand is high, it will scale out. And when the demand is low, it will scale in to your desired capacity. Maybe your minimum capacity is 2 instances and your maximum may be 6. And maybe your desired capacity is 4. So it will just be there in between. You don't have to worry about scaling it. Maybe there are no users or there are users. You just have to feed it with the information and it will do it automatically. So I'll find the auto-scaling group somewhere here. Auto-scaling. So for auto-scaling, you have to create auto-scaling group for front-end service and an auto-scaling group for the back-end service. For the back-end service, it can also scale in and out depending with the traffic. And to manage traffic, you need a load balancer so that you can balance traffic to your instances. Load balancer. You can see that this is easy. It's easy to just drag and drop images and come up with a nice architecture. Of course, better than mine. So you need a load balancer here so that it will take traffic from the internet and it will balance that traffic to either go to one instance or the other, depending with the rate of the traffic. Maybe there are 1 million people using your application. So the load balancer will take traffic to this one, the next one, and that, depending with the queue. So like when traffic comes in, they wait in a queue. It's like fast in, fast out. Yeah. So it will have to be like that. And also you have to place this load balancer on the back end so that the traffic coming in from the front end, when it goes to the back end, it will also be balanced to the EC2 instances. So with that, you have achieved scalability, availability, security, and cost. Yeah, and cost. So the final architecture should look something like this. You can see it from here. Okay, this CloudFront here is to protect the application load balancer from attacks. That's why I've placed it here. You can see the internet gateway, which allows our public subnets to interact with the outside world. And our NAT gateway is to allow our private.
Sorry, Marcrine.
Yes.
I think CloudFront is mostly a content delivery tool. If you want to prevent DDoS, maybe you should consider WAF.
Yes, but also the CloudFront protects the ALB from attacks.
Yes,
somehow.
it does.
Okay.
I'm just saying there are tools to do a better job. It also does, but the WAF is a better option.
Yes.
The
yes,
CloudFront
that's
is
true.
more focused towards content delivery.
Yeah, for caching content. Okay. Yeah, that's true. So you can see the whole architecture. It's highly available, scalable.
I think also I have another question.
Yes.
The NAT gateway
Yes.
is to allow the private subnet access to the internet. So should the
Yeah.
NAT gateway be more on between the public and the first private gateways?
No, the NAT should always be placed in the public subnet. Always.
Okay.
Yeah, it's always in the public subnet.
Okay.
And then you can associate it with the private subnet.
Okay, thank you.
Yeah, it will allow servers in the private subnet to interact with the outside world. Yeah, and I think I'm done. You can ask your questions. Anyone with a question, maybe you can type. Patrick?
Wow, that was awesome. That was awesome. Awesome, Marcrine. You've done an excellent job. Yes, the floor is now open for questions. You can take questions for the next 5 minutes before we end the session. Any question, any comment, any addition? Thank you to Maini for your input. Someone is talking?
Awesome. Yeah, I've learned. I'm still learning. So far, everything looks good. Asante sana.
Awesome.
Everyone has understood.
Yes, there is someone that has a question.
My question is about security groups.
Yes, go ahead.
Are we going to add them?
Yeah, you need security groups to protect
the other question is about knuckles. That is where we place the knuckle in the diagram, in the drawing. Okay.
Yeah.
So if I have only one knuckle that is set for all the subnets, where would I be?
Okay. You can just use the same knuckle for all the subnets. But
and where would I place it in the diagram?
In the diagram, you have to place it on each subnet.
Maybe bring the diagram back so that we can have an idea while we are looking at the diagram. You can share a screen again.
Okay. Yeah. Can you see it? Yes, you have to place it literally on all subnets, but it can be the same knuckle with the same rules. So there is no big deal. Yeah.
Wait, I still have a question.
Okay, yes.
So you're using one knuckle for all the subnets?
You can choose to use one knuckle for all subnets, depending with the requirements of your subnet. But you can also choose to use multiple. It will depend with the rules. If the rules are the same for all subnets, why not use one knuckle? But if there are different rules, you can use different knuckles.
So for this architecture, what is the case?
Different knuckles.
Okay. So thanks.
I think to make it easier, I should have had one box knuckle for the public subnet and one box knuckle for the private subnets.
Yeah, okay. That's true. Patrick, I think the rest of the questions, maybe they will inbox us.
Yes. So guys, I can see we are running out of time. We have 2 minutes for the session to auto end. So let me take this opportunity to thank all of us for coming out for this session. We hope that the next time we call you, you'll show up, upbeat and ready. We are looking forward to another member of the group walking us through Challenge 2 next week. So we will announce to you guys when we will be having our session. So thank you so much for coming out. Thank you, Marcrine, for taking us through that session. And yes, Thank you. Hope to see you again next week. So from us here, we wish you all the best. We wish you a good evening and have yourself the best one. Goodbye, everybody.
Bye.